Greetings, this is Mark Anderson for Kellogg Community College, and we are going to look at some linear functions today. For the first part of this two-part video, we are going to look at introducing the point-slope form and the slope-intercept form. And I believe the book is going to be pretty particular about which form it wants you to use in your homework. I am going to basically ask you to use one or the other. The slope-intercept form is y equals mx plus b. M being the slope, and B being the y-intercept. And it's important that the y-intercept is a location usually indicated by 0, comma b, because if I'm on the y-intercept, my x value is 0. And therefore, I will then know, if I give you a point in the form of 0, comma number, I am on the y-intercept, and that is the y-intercept, which saves me a bunch of time. The point-slope form here is y minus y sub 1. Ooh, I wrote x. Excuse me, a little flub on my writing there. Y minus y sub 1 is equal to m times x minus x sub 1. And let's stylistically make that a little bit darker there, because this is basically going to be from a slope and a point that this line goes through. Now, the point-slope form is newer for most students. We start off usually in middle school or early high school by showing people the slope-intercept form, which is this y equals mx plus b. We're going to actually show in each of these problems both equations, and we'll see that there are some pros and cons of each as we go through. Now, the first thing we want to do is use the slope-intercept form if I give you the slope and I give you the point. So this is y equals 2, because that is the slope of the problem, and the point is 0, comma negative 4. This happens to be a y-intercept because I gave you a 0, comma 4, so what we can literally do is just plug the 4 in for the y-intercept spot, and we have our answer. So how would the point-slope form work with this? Well, what we would do is plug in the point and the slope, so this would be y minus minus 4, because this is the y value of that point, is equal to 2, this is our slope m, and then we would plug in our x there for x minus 0. And what we would then do is just simplify this. This would be y plus 4, this would be x minus 0, which is x, times 2, which is 2x, and that's our point-slope form. You'll note that the point-slope form is only one step away from being slope-intercept form. We need the slope-intercept form because that's how we would type it into the graphing calculator. The point-slope form is very useful in finding any point anywhere in the future, but it doesn't actually come ready-made for graphing. But you're one step away, so if you could learn the point-slope form, you'll enjoy its flexibility, especially when getting to the end of this worksheet. So for our second example, we're going to find an equation of the line that has a point and a slope. Now, in this case, you'll note that the point that I'm giving you is not, I repeat, is not the y-intercept. So here I have my y equals 1/2 x, but I don't know what my b is. I don't know what the letter that represents the y-intercept is, because negative 2, negative 4 is not the y-intercept. But if I plug that negative 2, negative 4 into my equation, like I'm about to do here, or I'm doing it right now, this is actually going to get us a letter b. So this would be negative 4 is equal to negative 1/2 times negative 2 is negative 1 plus b. If I add the 1 to both sides, what I now have is b is equal to negative 3. So now my equation is y equals 1/2 x minus 3. There's my equation in slope-intercept form. Now the point-slope form is going to start off with that y minus y sub 1, and then x minus times y minus y sub 1 is equal to the slope times x minus x sub 1. Well, here we have our, this point-slope form is made for this because there's a point and then there's a slope. So y minus minus 4 for my y value, for my y minus negative, or y sub 1, is equal to my slope of 1/2 and then x minus negative 2. I will do some simplification here. This is y plus 4. I'll do some simplification here. This is 1/2 in parentheses, x plus 2. I'll distribute my 1/2. So now on the left side, I have x plus 4. On the right-hand side, I have 1/2 x plus 1. And there's my answer there. my answer is after I've simplified my point-slope form, you'll see that I'm just one step away from this being into slope-intercept form. But if you just want to use the slope-intercept form, you can. So just subtracting 4 on both sides, you could see the equivalent equation. So for our final problem on this worksheet, we're going to find the equation given 2 points. Now you'll note in this problem I did not give you a slope, but we can easily find slope by using the slope equation. The slope is going to be equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What that means is that you should subtract the y values and then in the same order subtract the x values. So here's xy, here's xy. So literally if you want to go that this is 2 and 1, you can. You can also call this 2 and 1, you can. But you would get the same answer if you subtracted them in a different order. But let's actually find the slope now. We'll find the slope, and I'll change this to a new color just so you can see that we're actually using the slope for both problems, whether we want to use it in slope-intercept form or point-slope form. So I'm going to go negative 17 minus negative 7. That was my y sub 2 minus y sub 1. And then I'm going to go negative 2 minus 1. Negative 7 minus negative 7 is the same thing as saying negative 7 plus 7, negative 17 plus 7, or negative 10. Negative 2 minus 1 is negative 3, so my slope in this case is going to be the simplified form of negative 10 negative thirds, or 10 thirds. So I'm going to use that inside of my equations over here. So in my in my slope-intercept form, let's go with black here. In my slope-intercept form, which is y equals mx plus b, I'm going to plug in my m, which in this case is 10 thirds. I'm going to analyze my 2 points. Well, it's unfortunate that my 2 points, neither one of them is a y-intercept. So I'm going to plug my y into this equation. There's y for my negative 7 and 1 in for x in that equation. And I'm going to solve for b. A good question at this moment is like, why did you pick this point and not this point? Well, the reason why I picked this point is that it had fewer negatives. I literally could have picked this other point, but since the numbers are slightly larger and both numbers are negative, I'm going to stay away from this example. So negative 7 is equal to 10 thirds plus b. If I subtract 10 thirds from both sides, this would actually be negative 7 is equivalent to negative 21 thirds. I would get an answer of negative 31 thirds, or negative 10 and a third. You could also use a decimal if you'd like. This is going to be my y-intercept. So my equation is y equals positive 10 thirds, which was the slope we found over here, x minus 10 and a third, or 31 thirds, or negative 10.3 repeating. So now let's look at our final form, the point-slope form, and this is something maybe in the video up to this point you've been resisting learning, but there's something kind of cool about this. You saw all the work in this black ink here of what we had to do when we had to get 2 points to make a slope and then find the point-slope or find the slope-intercept form. Well, watch how cool the point-slope form is, because it's y minus y sub 1 is equal to m times x minus x sub 1. How quick is this going to be? I'm going to pull from the point up above here, so y minus minus 7 is equal to 10 thirds. We pulled from the slope over here. And then x minus, we'll pull from that up here, x minus 1. So now I have y plus 7 is equal to 10 thirds x minus 10 thirds. And we can see that we're actually one step away from the problem and we're finished with it because we did it in point-slope form. But you see the slope-intercept form actually requires more work because you have to find that y-intercept. Here in the point-slope form, if I wanted to find the y-intercept, I just subtract 7 from both sides, and we saw what negative 7 and negative 10 thirds made. It would give us the correct y-intercept there. So, in essence, this is my opinion. But if you're struggling, you should probably stick with the slope-intercept form because it's what you're more familiar with. But if you've leveled up enough that you kind of feel like you're okay and ready for the next challenge, why don't you give the point-slope form a try? You can see that in this third example, one of the more trickier problems, it actually took a lot less time to finish it. And since it wasn't looking for slope-intercept form, you didn't actually have to do any final steps to get this into y equals mx plus b form. So the point-slope form is pretty versatile because it does actually get you pretty close to finding the y-intercept, even if it doesn't, have it right in front of you like is on the slope-intercept form. But again, if you struggle, stick with the left side, and if you have leveled up, go to the right-hand side. I think the higher you go in mathematics, the more point-slope form gives you exactly what you want. Well, thank you very much for watching. Stay tuned for more videos, especially the next one in this series, talking about linear functions dealing with parallel and perpendicular.